So thank you all very much for coming. It's always a bit of a challenge to have these meetups during the summer here at Bol.com or during the late spring, because of the way that the setup is orientated. Everybody gets to see outside exactly what kind of nice weather they're missing while they're sitting inside listening to people talk about tech. But hopefully we can make up for that with a really interesting presentation from René from MessageBird, who will be speaking to us about this particular topic. We're really thrilled to have him here, because we are going through, as a company, going through this transition to the cloud, and that's something that MessageBird is already is a lot further along, or perhaps even finished. He will explain in his talk. So on that front, we're really happy that he's here to tell us about his particular journey. The MessageBird's particular journey to the cloud, and then afterwards I will tell you a bit about our journey to the cloud, what we hope to achieve, why we're doing it, and some of the lessons that we have learned along the way. I'm really glad that you have all made the trip to join us here. I hope everybody has had dinner and enjoyed that dinner. If not, it was free, so don't complain, please. René will speak, then we'll have a 15-minute break, and then I will speak, and then there will be time for drinks if any of you still feel up to it at that point. This is being live streamed on YouTube. I'm not entirely sure what the URL is, but I'm gonna try and find out and tweet that out so that people can log in if they're watching the Twitters. Yeah, that's it basically. We'll do questions at the end of your session. I'll walk around with a microphone, and yeah, that's it.
Cool. Thanks, Maarten, for inviting me and Bol. So I'm René, Director of Engineering of MessageBird, as well co-founder. We started 8 years ago. I'll go through that briefly in the beginning. So what are we going to talk about today? MessageBird and CPaaS. What is MessageBird? Who is MessageBird? And what is actually CPaaS? Why did we move to the cloud? And how are we benefiting from that? The migration. How did we did that? Are we finished? Yes, no. How do we see that? And post-migration, what are the things that we are now benefiting from being in Google Cloud? And the takeaways and learnings that we had over the years, over the last year that we after migration, and Q&A if there's anything you like to ask me during the session, and I'm also available after the session. So MessageBird, what is MessageBird? MessageBird is a cloud communications platform, and we offer cloud communication services as building blocks for enterprises, small medium businesses, and also for wholesale companies. Our vision is that we want to make communication between businesses and consumers as easy as talking to a friend. And our approach here is to make APIs available for our customers, but also going the next level on software as a service for our customers, to be used as a bridge for customers that don't have the engineering power or the engineering resources or engineering time to implement our services. We started 8 years ago, and with SMS as primary product, we reinvented how we saw SMS should be done, not only the old telecom ways, but also the new telecom ways, creating APIs in 2011 fashion, and we kept updating that towards this point. And over the years after, we introduced other services that are complementary to communications, like voice over IP, voice APIs, SIP trunking, but also chat services, aggregating chat services like Facebook Messenger, Telegram, Line, WeChat, etc., bringing them together as one platform, so a customer of us doesn't need to integrate all these channels. They integrate MessageBird, and we make sure that we reach the consumers via the right channel. In 2017, we got a big Series A round. We got invested $60 million, and with that money, we are investing that in future, and which is more a global expansion, building new products and making our customers happier and bringing the communication between brands and businesses and consumers closer to each other and enabling that. So what is then a cloud platform as a service? I like to explain it a little bit like this. We are a building block for enterprise services and modern product development. So for payments, you use as a company starting up or scale up, you don't want to invent all that wheels, that kind of wheels, because you are focusing on your product. Uber is focusing on ride-hailing. Bol is focusing on selling products online. So they use payment service providers like Stripe and Adyen. They use location services like Google and Mapbox. They use compute and cloud providers like Google and Amazon. And for communications, they use MessageBird or Twilio. And in that way, we position ourselves like, okay, we are here for the business, for small, medium, enterprise, doesn't really matter. And you can build on top of us, and you focus on your own strengths. This is a little bit how communication looks like in a technical or an engineering way. We have a company, our customer. They can integrate with us in various ways. So we obviously have our APIs. We created a product flow builder. I get into that later. And then a lot of vendor integrations to make it easier to just click and play in Zendesk, Freshdesk, Salesforce, whatever, just to enable our services. Then we have a lot of technology to make sure that messages are floating or voice calls are going the right direction to the right user, cost efficient, etc. And then a lot of the things that we are doing is communication and telecoms. So we are connected with a lot of carriers to make sure that SMS messages or phone calls are delivered. But also, since the last years, we introduced third-party services or over-the-top services like WhatsApp, RCS, Line, Telegram, like I said. And we are aggregating all these channels for the businesses. And then we have Flow Builder. And Flow Builder is a tool that enables no-code solutions for our customers. So in a lot of cases, our business or our customers or potential customers don't have either the technical ability or the resources to implement our APIs. They're just too busy, somewhere back at the roadmap. So what we invented is a drag and drop call flow generator UI, which actually in the back end just pulls and configures our APIs. But in this way you can configure incoming calls, IVR systems, what to do when an SMS arrives at our systems, etc. Without writing a single line of code and just by logging in our dashboard. So this is a little bit the introduction of MessageBird, and then why moving to the cloud? So for the first 7 years we were on-premise. We had a private cloud, on-premise solution, whatever you call it. A lot of it was already virtualized. Some things were still hardware, and it took us a lot of time. So the first I've chosen 4 main reasons to move to the cloud, or actually we had 4 reasons to move to the cloud. The first one is focus on our vision. We are in Amsterdam. There is a lot of tech talent, but not enough. And with the talent that we have and good engineers and business development and product development people, we want to focus on a vision of creating a communication platform of the future. So we want to focus on our dashboard, on our SMS solutions, on our voice solutions, whatever. We don't want to focus on infrastructure. And we want to be close to the customer. Close to the customer in both ways, our customer, but also their customer, the consumer, end user. And to do that, especially for voice or real-time services, you want to reduce latency, so you need to be close to the customer for more textual communication doesn't really matter if you have 200 milliseconds delay, of course, but for voice it's super important. So we need to have a lot of points of presence. We can build it ourselves, but that will remove the focus from building the products to creating the infrastructure. Scale. And easy to scale. We are growing fast, really fast. And to keep that up, then you need, again, a whole infrastructure team that is either managing hardware servers, or you have a third party that is managing this. But we are never able to scale as fast as we are able to do in Google Cloud or any other cloud provider. Turning on servers, but now these days also Kubernetes pods, clusters, etc. It's too convenient to reinvent that. And a third party, the fourth reason is cost of ownership. To do all these things ourselves or buy it from somewhere. In Netherlands, it's doable. In United States, it's doable. But if you want to do that, it's 4, 6, 8 locations worldwide. It's a lot of management, a lot of cost of ownership, and a lot of need for knowledge. Because we tend to think that Google or AWS is better at this than we are, because we want to focus on our strengths. So we made a decision, we go to the cloud. We made a decision, which cloud provider. Then the next question is, okay, let's do this. So a simplified image, just also to have this dialogue. We had a private cloud and a public cloud. We already tested some cloud providers. We ended up with, in this case, Google Cloud. We spun up some services, some new services over the years we already developed there. So we got our learnings. And this was the situation before we did our big migration. So easy as this, we pick this up, we put it there, all done. That might have been possible if we were not thinking about the customers. Because all these people are reliant on our services. This guy in the call center is having a conversation with a customer. We can't just break their conversation and say, yeah, now we are down for 3 hours because we're going to migrate. Same for this guy waiting on his Uber. He just received the number sign of the Uber, so he can recognize which Uber he needs to take. He needs to receive that message. And also the next customer of Uber needs to receive that message. On the right-hand side, we are doing Google OTP messages, two-factor authentication. This woman would be very annoyed at Google, not at us, if she could not log into her Gmail to check her mail. And this little guy might have missed his medicine because a WhatsApp message didn't arrive to his mother to notify her about taking a medicine. So we need to take another approach than 3 hours downtime scheduled, because that's not working for us and also not working for our customers. And I think we would lose a lot of customers if we would do this. And that's also the difficulty of our product. Even 5 nines uptime is not enough for our customers. So preparation is key in this matter. We did extensive planning, step by step, go through all the components that we have. Did dependency analysis, which parts can we already move, which part can't we move, which part are not even able to move, and we need to keep at our current infrastructure, and we need to find another way to do this. And we need to do this with the whole team. Not only with a small engineering team, just not allocating this group of bright engineers saying, okay, you're going to fix this for the next couple of months. We need to do this together in a whole organization. How to do this? We need to create movable components, because we can't move everything in one cycle. We can't oversee this. Back then we had about 50 engineers, not a lot, and not a lot to move about 100 components. So with our planning, we identified the components that we need to decouple, that are too big to move as an individual component, so we need to split it up in small parts. We introduced a lot of data interfaces between the components, APIs or other ways of asynchronous communication between services. For every component, we decided where the data should be. We used to have several monoliths, and that was awesome because they all connected to the same database and they can read from it. But that doesn't work if you split up these components and then move one part already to the next data center and the other part is still in the old data center. How are they going to read the accurate data? So creating data APIs to make sure this customer data is always coming from here. This SMS is always stored here. And introduce a lot of elasticity. Making sure that a component can break. How do we retry? Do we fail? How do we inform our customer? How do we inform ourselves? Monitoring, stuff like that. Movable components were key to move to the cloud. And then lift and shift was the idea. Don't introduce new services while moving. Don't think, hey, this is great here in a VM, but let's move it into Kubernetes because it's there in Google Cloud, and let's do that while migrating, because you introduce so many new uncertainties. It's almost undoable to debug that, especially when you're moving, when you have stress, when you try to figure out things, is it working or not? So start using cloud services, all great, before or after migrating. You can already use a lot of services from your own on-premise data center. You don't need to be in their data center to use them. Sure, you have to enable some underlying network security or using SSL or whatever, but you can already move this. But don't introduce new things while migrating. Automate. Automate the way you're doing, especially in lift and shift. You think, yeah, okay, but maybe now it's shitty and we'll move it first, lift and shift, and then we will improve it. So let's not automate it now, let's automate it later. This is the moment. This is the moment to do it right again. It's most of the time clean sheet, at least provisioning of the project, provisioning of your servers, provisioning of whatever, provisioning your privileges. This is the moment to think clear about role-based access control, groups, roles, privileges, etc. Because the moment that you give my user access to this role, then then Faizan, my colleague, sees that and says, oh, okay, now I give myself also access, and then roles are gone again, and you have to start all over again. And so introduce repeatable process, because you will try this, it will fail, you have to throw away your VM again, do it again, and you want to automate this as much as possible. Use Ansible, use Terraform, use Deployment Manager, use something to automate your deployment process. Data management. We store a lot of data, and a lot of companies store a lot of data. So during this planning, find out where your data is. Which data do you need now? Which data do you need later? Which data can be lost or missing or not available, maybe that's a better word, for 10 minutes, 10 hours, or 10 days, and eventually be in the new location or the old location, and know which component needs it at which moment. So can we move it now or later during the deployment? When do we need to move the data or synchronize the data, replicate the data? It's super important to have insights into that, because that saves you a lot of stress again during migration. So actually treat data storage as a component, as a separate component. Does it really matter if you add 7 milliseconds latency to retrieve this one record? Actually, it shouldn't matter, because in Google Cloud or in AWS, sometimes you also see 10 milliseconds extra latency to your database because of weirdness. We figured out, or we experienced, in the cloud, you get way more weird stuff than in your on-premise predictable data center. So also treat data storage as a component and introduce elasticity. Such a hard word for the Dutch people, at least for me. So, and avoid one-way streets. Create two-way doors. Make sure that if your migration is not working perfectly, that you go back, that you are able to go back, roll back. Think about the state. Do you need to save state or current state in your application during migration? Or is eventually consistency good enough? And this impacts a lot of the way you and order of your component migration. Because some things, like I said, data you can already move, or you need to set up a whole replication, inter-data center replication, or even circular replication, because you need to know, even if you migrated and you want back, that your data is also back in the old data center. It's all possible, especially with simple, quote, quote, solutions as MySQL, Percona, what we are using for a lot of services. You can do a lot of cool stuff, interesting stuff, temporary. Don't do this in production, although always. But if you need to introduce this during migration, and it has and you benefit a lot from that because you can roll back, it's super important. I think these are the 6 points that we took into account, and then we already prepared the public cloud data center already. So what we did is we set up database replication, one-way, two-way. We already started to use some Google Cloud services. We already moved some data storage services, used the bucket services already, for example. Now, we are already using some components of some applications in their data center. We made sure that all the connections were secure. Either we use Cloud VPN, and when you need more throughput or even more reliable connectivity, all cloud providers support data center interconnectivity. It's a little bit more expensive, but you get a lot back from that. And we already created the leased lines that we have with our carriers also in the new data center. Data centers, regions. Migration day. Phase. We are not doing this in one day. And even one component you are not, or at least we were not moving one component in one day. It was a phase. And it was exhausting. So you don't want to do this in a weekend. You don't want to do this in one day. You want to really plan this also out. So during my migration phase, we did a couple of things that also contributed to a successful migration. We had a daily team gathering, at least at the days that we were doing migration or after migration or whatever, the whole team was together. Everyone had a role. Every engineer during migration, not the whole team, but then we said, okay, we are going to move this component. This team is knowledgeable about this component. Then we added some more people saying, okay, you should learn also from this. And then this one was a tester. This one was monitoring, just watching the monitor. This one was actually executing this, etc. So everyone had a role, and then we executed disciplined. Following the plan, we tested the plan. We made sure that we were able to roll back. We made sure that before we migrated, we know how to roll back, and we did it component by component by component. And yes, this was tiresome sometimes. It was exhausting, but it was also fun. We learned a lot. Not only about Google, not only about how networks work, not only about how to restore database dumps, but also about each other, about the team, and about our own product. Because a lot of people got introduced to our product engineering team after we built this one component, and then new people joined, learned a lot, etc. So, example. Let's move this component. Again, this is an HTTP web service available from the public internet, and we want to get it from there to the other side. So at this moment, I removed everything that's not relevant for now, but just to simplify it a little bit. Traffic is coming in from the internet, going through a load balancer, and hitting this application, and this application is using a database cluster or database replication set. Remember what I said, we need to keep as long as possible a two-way door. So we deploy this service over here. It's also using Google, some service in Google. So through the VPN and also directly in the public cloud, it's using this service. And we are going to read and write from the database on our old platform. Still two-way door. If things are failing, then we are still reading and writing to the same infrastructure. Then we can send a little bit of traffic. Of course, we tested this first, but on migration day or migration phase, we can send from our load balancer in our old platform to the load balancer in the new platform a little bit of traffic. Be careful about IP masking or IP proxy, etc., etc. But if you got this right, then this traffic is coming in 1%, 5%, 10%, whatever, into our new application. We can verify this. If it's not working, we go back. And you can really do this on IP basis or on source basis. Maybe you can even, depending on your load balancer, you can do fancy stuff. If it's working, we remove this one. So all traffic is still coming in. For the customer point of view, it's still going into the private cloud and ending up in the public cloud, still using a database. You can do this in 5 minutes. Let this be the status quo. You can take 3 days to make sure this is working. Also depending how much traffic is going to your database and if this lease line or VPN or whatever data center interconnectivity is working. So this is working. Then the replication was going on here from this DB to here. So at a certain moment you can say, okay, switch. But now we broke our two-way street. Now there's no way back anymore. Because this data is never going back here unless we created a circular replication. We try to avoid this as much as possible, but sometimes we needed it. And then we can do a DNS update and wait until all this traffic is flowing in to our new data center. And then we tear down this. Do this not the same moment, but do it fast because otherwise super confusing. And this database cluster was also used for other products, so we left it there. And this was a zero downtime migration, which we did a lot of times. And every time we went back to the team gathering, what went well, what went wrong, what do we improve, how can we learn from it, do we need to adapt the plan a little bit, and then the next time it will be better, faster, etc. Champagne. Karaoke, the whole shebang. No, this was not. This is our team, but we celebrated with Google together. But also we give ourselves a lot of high fives. Celebrate small success is, I think, super important during this phase. And yeah, this was awesome. Post migration. What did we do? We used some cloud services, not all of them. We thought very carefully about, again, two-way streets. Do we really want to implement this super interesting but super googly service that another cloud provider doesn't support, or we can't replace with something else like Kafka or whatever? Again, we're thinking about two-way streets or two-way doors in this infrastructure. And also, some services just don't work for the scale we have. Cloud SQL is great unless you do a lot of traffic. So we also maintain still our own Percona clusters and replica sets in Google. We use a little bit of Cloud VPN, but we also use our appliances software. We still need to be very tedious what we are going to use and what we don't use from Google or AWS or whatever, because they like to log in, of course. What are the takeaways and learnings that we got from moving to the cloud? One, we learned a lot about our own product. My new colleagues learned a lot about our new product, about our architecture, things that are amazing, things that are definitely technical debt, and we need to improve. And we improved during or after we migrated. It's a program. It's not just an epic on your backlog. It's not just one feature on your backlog. It's a program. It needs company buy-in, management buy-in. Not even the CTO, but also the CEO needs to know that this is going on. Also, your colleagues from customer support or sales or whatever, business development, they need to know this is going on because it will slow down a little bit other services or other efforts. But there is sun, and at the end of the horizon, it takes a long time, but eventually you'll get there. And you need to reinvent your platform or infrastructure team, because it's not that they are now out of job because you moved from on-premise or from other cloud provider, from private cloud to public cloud. They need to support again this product engineering team with repeatable services, with scripts, with monitoring services. They need to teach the product engineering team a lot about how the cloud is working, because the cloud comes with a lot of upsides, but also with a lot of downsides or unpredictable stuff that you never have in your public cloud, in your private cloud or on-premise cloud, on-premise data center. Yeah, that was it. Thank you. Any questions? Yeah. Oh, wait for Mike.
The stream can't hear. All right, I have a question about, you were talking about basically doing a code freeze while lifting and shifting.
Yeah.
Are you talking about the complete platform or only the component you're lifting and shifting?
Only the components you're lifting and shifting.
And how long did the code freeze take per component?
Little bit was depending on the situation, but from a couple of days to a couple of weeks. Okay. But some components are actually never touched, right? They are there. We have components that are running, they're working, and actually you could lift and shift them unless you want to introduce new services or use new services from the Google infrastructure in this case. So. But yeah, some services were not being touched for a while or code freezed because of this.
And were you actually able to lift and shift everything, or did it take some change?
No, so a lot of change, we did change a lot, but never introduced new things during migration. So let's say we were never migrating a service that was using making this up, but Kafka in our old data center and PubSub in our new data center. That's something new that you don't want to introduce during migration because you have no clue what's going on. So either you already use PubSub from your old data center and then migrate, or you or you set up a new Kafka cluster in your new data center, or you use the old Kafka cluster from the old data center while migrating to the new data center. But these new things you don't want to introduce during migration because you have no clue what's going on. Oh, yeah.
So basically you just walked in your local server room and you took the servers and you copied them to Google Cloud.
Yeah.
So there was a lot of...
Yeah.
All right. And so even your database servers were just copied over there, Kafka, your data storages.
Correct.
And did you stop using them now?
The old ones?
No, yet. I guess so, unless you want to burn the environment and have some free electricity. But now, are you now moving to, like you said, you didn't start using googly stuff, but
not for everything.
No, so you're still not using, I don't know, database clusters from Google or.
Not for all our services.
All right.
So some services can fairly thrive on work on the Google services. Some, in our experience, not yet. To give you an example, we are using Spanner for some services. We didn't migrate or migrate all our MySQL-like services to Spanner. One, it's way too expensive for everything, but also sometimes it just doesn't work. Same thing for big table or big query. They're all use case specific, and we really looked at, okay, what is the use case? Can we use it? Will it scale? Will it hold our current traffic? Will it hold our 5x traffic? Will it hold our 10x traffic?
So no deployable code yet, or lambdas, or.
What do you?
Well, AWS has these lambdas where you can just deploy some code and it will run in the cloud. No serverless code, but you're not.
Yeah, but that's still possible for some services.
Yeah.
Like we created over the years like 100 to 150 services. Some are, oh, I didn't touch it even. We're using their goodies sometimes. We moved applications from VMs now to Kubernetes that are now endlessly quote scalable. But for some services, it doesn't really make sense to do this. It takes a lot of effort. You don't gain a lot. So, and that's a little bit how we approach problems anyway. Does it make sense to change it? Yes, no, and then we move.
Yeah. All right. Thank you.
You said that there are a lot of downsides for using a cloud.
There are some downsides.
Yes. What are those downsides?
Your problems are not solved. Your infrastructural problems are not solved by moving to the cloud. Which is fine because you're used to having infrastructure anyway. But if you deploy your VMs in the cloud and say, now all my problems are over, that's not true. You still need to think about multi-data centers, multi-zones, multi-regions, however you want to like to approach, and what do you want to offer your customer. Maybe they are fine with incidents once in a while, because now you also have only one server and it's going down once in a while. So this kind of stuff, we need it. We need 4 nines, even 5 nines sometimes for some services that we offer. So we really need to think about, okay, reliability, uptime, availability in that sense. If you just cater for the Dutch market or the Western European market, there might be other solutions or other suppliers that are maybe more cost efficient. That are the main reasons I can think of. Maybe you have some more?
Well, you do lose some controls, especially like networking, how you used to of managing your own network. You do lose a lot of control on that. You relearn where the limitations are. So it's not all bed of roses.
Yeah. Does that also create a lot of dependency on the cloud, like on-premise systems, like you have a lot of access rights, the administrators basically, but on the clouds you don't have. For example, to the data clusters, you will not have the direct access to them, right?
You can get it, but you have to pay for it.
You have to pay for it.
But yeah, if you're from network point of view, yeah, you could say, I want to put Cisco firewall or a Juniper firewall. You don't do that type of decisions anymore. So there is some loss of control, and you have to be careful about that.
Okay. And did you also face some latency issues in the database? Like you were saying that there are some latency issues within the cloud for like 7 milliseconds of the time that comes.
Yeah, I think if you move to the cloud or to more losing a little bit of control and predictability of how things are working, where is your things like where is your node deployed in the data center can vary per deploy, or especially if you're using Kubernetes and preemptible nodes. Sometimes your server is there, sometimes your server is there. If you don't think in your application development about, okay, it's now possible that it takes 10 milliseconds instead of 1 millisecond, then at least unpredictable things are happening. Maybe, and it's not bad, but actually your systems get more reliable when you think about these things. But in a lot of cases, when you're used to on-prem development, let's call it like that, you don't think about these things until you experience it. There's also one in the back. Right? Yeah.
Thank you. When distributing your database cluster and your data all over the world, how did you make sure that you kept compliant to, for example, things like GDPR?
I never said that we are distributing the data all over the world. This was only about migrating from one data center to another. But again, per system or per service, we have either on-prem or not on-prem, on location or regional data storage, or we synchronize stuff. Some things you need everywhere.
Yeah.
But I think that's not part of this talk. How to create multi-regional services is a whole other topic. Yeah. I'd like to discuss that after this or another talk. But yeah, this was one one data center to one region. So actually 3 data centers.
Yeah, right. Thanks.
Yep.
What were the biggest surprises, both positive and negative, either technically or culturally?
So the biggest surprise was on culturally, you said, right?
Technically or culturally, like
So-
how the team coped?
Yeah. Yeah, I think the most non-technical, the amount we learned in this phase or in this project, even myself touching things for a long time and not anymore. I didn't touch things a long time anymore. How things were working, how things were evolved in a positive way or negative way over the years because other people worked on this, and also the knowledge sharing with others. And actually, because it had company buy-in, it had department was all focused on this for a long time. Not more for the majority. The team spirit was high. We were doing this. And pulling it off, and it worked. On technical level, surprises were more on. This is working weird. How why is this developed, or why are they offering this service like this? And then we ran into problems, and like, how can it be that no one told them yet that this was a case? Is anyone using this? Or this library? Google has a lot of great libraries or SDKs, but sometimes we found bugs in it. And like, okay, do we use it wrong, or is it not used? Or so stuff like that happened multiple times, and that was. Yeah, maybe that's also one of the downsides. Yeah, but looking back, actually it was I got out more positive than negative on the experience, but also on the outcome.
So your aim on the get-go was to prevent like vendor lock-in or just prevent a one-way street, you mentioned. And you also mentioned that you wanted service to be able to be deployable on AWS or whatever. So what actually made you choose Google Cloud in the first place?
We chose Google Cloud a long time ago for some services that especially required BigQuery, Bigtable, those services that were actually super Google specific and AWS couldn't cater for back then. And then based on our experiences that we had, the positive experiences building that, getting their help, them having a proper office here in Amsterdam, here in Netherlands, in Amsterdam, were reasons to choose for them. And the fact that they were actually the fast second on the cloud was also for us a reason to say okay, they learned from AWS and they did it better themselves. Not said that we will never go to AWS or Azure or whatever. Also, for example, parts of our infrastructure is in AWS because back then Google didn't have a data center in Australia. And we needed Australian footprint, so we chose AWS there. Great, thanks. 50-minute break.
Okay. Let's do a 10-minute break. I mean, 15 minutes. You all had plenty of time to get drinks and get food beforehand. So 10-minute break, and we'll restart at 5 till. Please rejoin. All right. Thanks again to René for his talk. I couldn't help but notice, René, that there's a whole bunch of MessageBird themed swag here. I assume you didn't just bring that for decoration. So people that are interested can contact René after this talk. So I'm going to tell you a little bit about. All right. I was going to say, well, cloud adoption at Bol.com. I noticed, René, you mostly stayed over here. I'm going to walk around a bit more, so camera people will have to get a bit more exercise. So yeah, let's get started. Yeah, it really is a pity that that monitor doesn't work. And let me try and fix that. Sorry? Oh. All right. Well, yeah. I always hate. Okay. It gives you a headache constantly having to do this all the time, but I'll manage. So. A bit about me. My name is Maarten Dirkse. I'm a cloud advocate, which means that I make people inside the company enthusiastic about going to the cloud, and I make people outside the company enthusiastic about how we're doing that. That I realize that makes me sound like some sort of motivational speaker or enthusiasm guru. I guess I kind of am, but I'm also a platform architect, so I also deal with the quite technical side of how we are moving to the cloud and exactly what parts of the cloud we're using. I've been at Bol.com for about 6 years and been witness to the amazing growth that we've had as a company. When I started here, the entire company was as big as the IT department is now. And the IT department is by no means the biggest department in the company. I started out as a Java developer, then spent a bunch of time in the CI/CD space, and now as a cloud advocate. But I was actually trained as a historian, and one of my professors at the university always used to say, as a historian, I can't predict the future, but when something has happened, I can explain to you why it could not have been any other way. And that's always kind of what I feel I'm doing with these presentations about how we're going to the cloud. All the stuff that happened up to now, nobody could have predicted it, but if you look back, then it really couldn't have been any other way. Then, a bit about the company which is hosting this event, Bol.com. Usually I do things like raise your hand if you've heard of Bol.com, raise your hand if you've bought things from Bol.com, but I imagine that's all that goes for most of you. Usually I make the joke like, I say like, raise your hand if you've bought stuff from Bol.com, and then I say, okay, you can stay, and then people usually laugh. But so we started out in a kind of mythical Porto cabin in Nieuwegein, which is just down the road here, and grew into a 1,800-person company that we are today. And along the way, we passed a couple of stages in terms of our IT development, and also as a company, we started out selling books and media, and along the way, we've basically evolved into a platform that allows anybody to sell stuff to consumers in the Netherlands and the Dutch-speaking part of Belgium. So we went from a shopping platform, which is basically we build a web shop, to a retail platform, which means we build a platform that allows other people and sellers, including us, to sell stuff with all the things that come with that, like billing and logistics, all that stuff made available to our sellers. Here are some Figures, if you're into that sort of thing. You can either be impressed by this or not, but these are the facts. Within the Dutch context, it's very impressive. Outside the Dutch context, perhaps less so, but we're still pretty proud of what we do. Speaking of the cloud, we run most of our stuff still today in our own data center. It's a data center that we built out in 2013. So we have a location in Amsterdam, or several locations in Amsterdam, that provide us with the square meters, power, cooling, and that's it. And everything else we supply ourselves. So we have people that go there and actually rack and stack servers, make sure that everything, the network cables work, etc., etc. People that are dedicated to building this data center. Before that, we were with another hosting provider, which had kind of a suffocating control over our software stack, which was good at the beginning of the company's lifetime, but was less good at the point in 2013 when we realized that we need to take control over this stuff ourselves. So moving to the DC, it actually removed the dependency on this external partner, obviously, because we were doing everything ourselves. We brought in a whole new range of engineers, or a whole new type of engineer, and new skill sets. A whole bunch of new people that actually helped us build up this infrastructure because we didn't have that skill set before. There we did we actually froze the entire thing. We also did code freeze for everything that was running with the old hosting provider. We did lift and shift. We actually did do a one-day migration. There was literally one day in which we flipped a switch and everything swapped over from the old infrastructure to the new data center. And that was on one night, and there are, as you might imagine, some epic war stories from that night about things that almost went wrong and like a disaster that almost struck, but then in the end didn't, and in the end everything worked out. So that's our data center, and we're still running, like I said, most of our stuff in the data center at the moment. So in 2017, we've been running this data center for about 4 years, and we were running this own data center. It was expanding all the time. We have this cycle in online retail that you do a lot of business during the whole of the year, but then during what we call the season, which is more or less from the beginning of November until Christmas, you do like 30% of your revenue basically, and in just those 2 months. And you need to make sure that you have enough hardware and enough resources in your data center to deal with that peak. And then what happens when Christmas is over? Well, then the usage goes back down. But our experience was that during the year that followed, pretty quickly the baseline would be almost the same as the peak was in the season before. So things were, we were buying more hardware, things were growing all the time. We were obviously getting, as the company was growing, we were getting more feature teams, more developer teams. They needed to be supported by an ever-growing number of support engineers. So these engineers, they're not support engineers in the sense that they tell people how to fix their Windows or something, but it's more like, hey, I want to run a new service. I need a VM. I need CI/CD infrastructure. Please arrange that for me, because it was stuff that the engineers couldn't do that themselves. Because of this dependency, the more feature teams we had and the more support engineering staff we also needed to have. We were building our own container platform. This sounded like a really good idea at the time, trust me. And it was pretty clear that the IT platform was becoming a bottleneck, because we built this container platform and we actually had it up and running. It was pretty cool. It was based on Mesos. It had an interesting networking stuff, and it actually worked, but it didn't do like a tenth of the things that Kubernetes would do for you, that Kubernetes does for you now, and also back then when Kubernetes was somewhat less mature than it is now. It was already apparent that we would never be able to match what Kubernetes was doing, especially things like GKE were doing, if we were to build this stuff ourselves, because it was kind of built in like some engineer's spare time, but at the same time it was the future of the company, so it was a bit weird. In any case, the IT platform was really becoming a bottleneck for innovation within the company. We were getting throughput time, starting new services. We wanted to move to a more fine-grained service-oriented architecture, and starting new services was just a real pain with all the dependencies you had. So it was obvious that something needed to be done. Just what was not quite clear yet, but people were kind of, they felt in their gut that we needed to make some sort of change. And so then something occurred to us. Something that in hindsight is really obvious, but as is always the case with these things. So we had three thoughts. The first, Bol.com is a retail platform company. It's not an IT platform company. What that means is that we are in the business of creating a platform for people to sell stuff to consumers. We are not in the business of running a data center.
There are some examples of retail platforms nowadays are running data centers.
Sorry?
There are some examples of retail platforms who are now really successful by running data centers and selling that out to other people.
Basically one example, you mean? Yeah.
Alibaba.
Yeah, Alibaba, yeah, that's true. So there's two, yeah. But yeah, that's true, but they did that a long time before we did, so we can now profit from their evolution. So, but it's basically the same as René also said in his talk. We want to focus on what makes Bol.com special, what our core business is, and our core business is not racking, stacking servers, making sure all that stuff works, developing container platforms, etc., etc. That's not what we should be doing. We should be focusing on building and adding features to that retail platform. Then the second, we as Bol.com can never out-innovate public cloud provider platforms in terms of the infrastructure that they provide. And we tried. I mean, we built this container platform, and it was functional. And we, at some point, we thought like, well, if we just focus on that thing which we need, so we don't need to replicate the entire Google Cloud or Amazon AWS, we can just focus on exactly what we need and do that really well, and it'll work for us. Even if we did that, we could still not compete with the offering of the public cloud. And that's because we simply don't have the manpower, we don't have the resources in terms of money, and we also don't have the interest, because of the point before, in doing this. So this was kind of like, oh, we'll never be able to catch up to them, and also we shouldn't even try because it's a huge waste of money and our time. And then finally, team autonomy. We realized because of this, what I talked about earlier with the support staff growing along with the feature teams, that we needed to make teams as autonomous as possible. We needed to enable them to do everything themselves for the, let's say, 80% of the stuff they needed to do, so that they would not be reliant on external dependencies. So the teams could go as fast as they could go themselves and not be dependent on anybody else. And if you wanted to do this in the DC, so the DC mostly runs on VMware for its virtual machines, that sort of thing. I am unfortunate enough to once have attempted some sort of scripting integration with the VMware vCenter. I still wake up screaming some nights. So that obviously wasn't a viable route to go. And in the cloud, obviously, this stuff is a lot better. So what do? We go to the cloud, because obviously it answers all of these, or it provides a solid underpinning for all of these things that I mentioned before. And this is a chart that was made as a part of the business case. So yeah, it's not super evident what you see here, but essentially this is the situation in which we stay on premise. Then we have the number of tools being managed that is growing steadily. We have the platform innovation capability that is rising, but we also have the platform operational, or OPEX as we call it, the operational responsibility that's rising along with it. In the cloud, we have the platform innovation capability that's growing. We also have the number of tools being managed, which is growing, but the operational responsibility of the platform team kind of, well, not really flatlines, but grows at a much less rapid pace, which means we need less platform engineers to support more feature teams. That was the entire point. So we were going to the cloud. Which cloud? So there's three major cloud providers, as I'm sure you all know. There's Amazon. Amazon, who happened to be a direct competitor of ours. So as you can imagine, management was not too keen on hosting all of our compute at Amazon. I'm not saying that they would throttle our CPUs or something just to troll us, but you never know. So so Amazon was clearly a no-go. Then there was Azure. Azure is actually the cloud provider for Ahold, who is our parent company. So the Ahold guys were like, look, we already have this contract. You can just sort of, if you join us, then our discounts will get bigger. So consider, please. But actually, our engineers, and this is a photo of an internal conference that we do each year with a bunch of engineers. Our engineers actually already had some experience with the Google Cloud, really liked the Google culture, the developer culture, the engineering culture, really liked the way that sort of Google contributes to open source as a company, and also really liked the way that the Google Cloud operates, rather, the whole developer experience. So the engineers actually prevailed upon management to go to the Google Cloud, and that's what we did. And that's something I'm pretty proud of, because it's not always that you hear stories about engineers sort of getting their way inside the company, but in this case, we did. And I'd like to tell you that that was the only reason, but there were also some technical and quite valid business reasons to go, rather than just the sort of warm, fuzzy feeling we got from Google. And that's Kubernetes. So we decided quite early on that whereas in the DC we have everything based on VMs, in the cloud we were going to base everything on Kubernetes. We were going to run everything in containers, specifically on Kubernetes. At that point, so we're talking 2 years ago, Google had, I think, by some distance, the best managed Kubernetes offering there was. Now you can kind of argue, because Azure and AWS have since taken steps to improve their offerings as well, but GKE is still a fantastic product, and we have no regrets. So GKE, Kubernetes, TensorFlow. So I'm sure you all know TensorFlow, the library. So we didn't go to Google Cloud for TensorFlow. We went to Google Cloud because they have TensorFlow is kind of a symbol for all the machine learning stuff that they do. They have a lot of great machine learning integrations with all kinds of products that they have. They have all kinds of really cool APIs that you can sort of use, and they just work. So the guys that do image processing for our sellers, they can just do an API call to the image API or the Google Cloud Vision API and say, hey, what's in this picture? And then a JSON string comes back with like a bunch of things that are in that picture. And I always say, like, if that doesn't blow your mind on some level, then you're really, really spoiled, because that's freaking amazing. So all sorts of things along those lines. Also, one of the areas in which Google is still, I think, quite far ahead of the rest. And then finally, BigQuery. BigQuery is a great solution for BI and data insight. And we were kind of on the clock with our previous BI solution, because the vendor decided to pull the plug on it. So we needed to move, and essentially BigQuery was the best thing out there at the time, and arguably still is. So then, apart from these things, when you get into Cloudland, you start to look through this giant catalog of stuff that Google offers you, and you start to realize that, well, everything that I might want to do myself, there's a pretty good chance that Google has already built something similar that I can just go ahead and use. So Google has this giant portfolio of all kinds of things that are all API driven and might be quite costly, like Spanner, but are available. And if you sort of crunch the numbers, then what I find is that it's almost always better to use the managed service, because running it yourself means that you have to dedicate engineers, et cetera, et cetera. So try not to reinvent the wheel when Google has already probably invented a really good wheel for you. And if you already have a really cool wheel that you invented in-house, and now Google is offering you this other wheel, don't be afraid to discard the wheel you already have. So at Bol.com we have an in-house messaging solution that we built ourselves. Also seemed like a really good idea at the time, but going forward we want to sort of get rid of it and move to PubSub, because obviously that is managed by Google, and the in-house messaging solution we have to manage ourselves. And it also makes experimentation really easy. So obviously in the data center, if you say, well, I want to experiment with something like Airflow, which is a big data technology, then you have to go and set that up, and people have to write Puppet scripts and do all kinds of things to manage that. In the Google Cloud, you can just say, please provision something for me, and you can just go ahead and use it. Again, it's all about focusing on what makes Bol.com as a company special, as opposed to running all kinds of generic infrastructure to support what we actually want to do. Who knows who this is? Werner Vogels. He is, so I got confused yesterday because he is actually the CTO of Amazon, and because I thought he was the director of AWS, but he's not. That's the guy called Andy Jassy. Anyway, so he's this guy. He's Dutch, and he's the boss of AWS, and he's famous for a bunch of things. But one of the things is going on stage once every year in Las Vegas at the giant AWS conference and speaking about how you should be using the cloud. And a couple of years ago, I caught one of these talks by him, and one of the things that struck me was when you go to the cloud, you can stop thinking in traditional DC limitations, and that's something that is really it's a huge sort of mindset shift if you're coming from a DC background. But to give you an example, if you want to launch a new service in our data center, we have this process that you have to go through where you have to specify a whole bunch of things that you expect to happen to your service. Like, I expect it will have this amount of load. I expect to need this amount of resources. I expect to have this many users use it, et cetera, et cetera. All this stuff you have to kind of predict beforehand, even though the prediction is pretty much crap, because you can't know what actually happens to your service unless you run it in production and go measure what it's doing. So you can do all kinds of calculations beforehand, like I expect load X, Y, and Z, but unless you actually run it and measure it, you don't know what you actually need. And in the DC, having to do this prediction makes sense to such a degree that if you find that you need a lot more resources, then you need to order more hardware, and that takes time. That can take 6 to 8 weeks before the servers arrive. In a previous version of this presentation, I had a screenshot of an internal mail that was sent by one of the guys running our internal messaging platform a year and a half ago that said, we've been experiencing some load issues lately, but don't worry, we've ordered a new server, so in about 6 to 8 weeks the issue should be solved. Great. Obviously in the cloud, you don't have to deal with any of that. If you need more resources, you can just get more resources immediately. And you can also kind of design and engineer as though you have unlimited resources. You don't need to worry about, well, am I going to, I have this server and it can only take this amount of load. Should I be, designing my software to deal with this limit? No, you can just design your software as though you have an unlimited capacity, and unless you are unless you are limitlessly successful, you won't actually need the unlimited capacity, but you can still design as though you have it. But you should be aware of the cost, obviously. The business case should be sound. Now in the DC, nobody knows what anything costs. Here at Bol.com, there was for a while the belief that we had one guy in the organization that actually knew what stuff costs in the DC, but in the end it turned out that they didn't know either. Because what happens is you buy these servers, these huge servers that you run VMware on, then you run on those, you run VMs that actually run the services, and then you have 2 services, and then by the time you actually get to figuring out what things cost with the CapEx and the OpEx for the operational expenditure, for the power, et cetera, it becomes a hugely complicated calculation that is almost impossible to do. Whereas in the cloud, you just get a bill for the project, right? It's just like Google says, well, your project costs X, Y, and your project costs this much, and you know. So it makes it really easy to reason about the business case. You say, well, we have this service that is doing this, which is generating revenue X, but it's costing Y, and Y is more than X, so let's not do this anymore. In the DC, those kinds of decisions are really hard to make because you don't have the insight. So, cloud is pretty awesome, right? But there are so many different possibilities that it becomes exceedingly easy to shoot yourself in the foot. When we were starting the migration, we had one of our security engineers do a little test where he provisioned the VM, and on the Google Cloud, VMs get public IPs by default. He left the VM up for like an hour or something, and then plotted on a world map all the places in the world where people actually try to break into that VM from. So within about 20 minutes, somebody was knocking on our SSH door from the Seychelles, and it must be really nice to be a hacker in the Seychelles. But so there's all kinds of defaults in the Google Cloud Platform which make a lot of sense for a lot of people, but might not make sense for you.
and you need to take care of the fact that your developer should not be burdened with making all those choices all the time. So we created a framework that makes doing the right thing on the cloud really, really easy. So what does this framework do? Well, essentially, this platform enforces security measures, so we never create VMs with public IPs. Storage buckets are always guaranteed to never be public facing unless we explicitly say that they must be. There's all kinds of things that you can do to ensure that the standard stuff that you provision in the cloud becomes a bit more safe, like associating it with your own VPC, that sort of thing. It should encode best practices, so if there are certain things that we would like to handle a certain way on the platform, then this framework should take care of that for you. So for instance, if we want to have storage buckets, and we always want to have regional storage buckets, for instance, because we don't need multi-regional storage buckets, then the framework ensures that when you create a storage bucket, it's a regional storage bucket and not, which is by default, a multi-regional storage bucket. These kinds of things just ease the cognitive load on the developer that doesn't need to think about these things that are basically taken care of for him. Right, exactly that point. But, so, it should be also easy to customize, because there are developers that say, well, actually, I want a VM with a public IP because I have a legitimate business case for doing that, or I want to have a public-facing bucket because I want to expose some files to third parties that need to be able to download it. So the framework should be based on a whole bunch of these conventions and best practices, but at the same time be easy enough to customize that people that have these custom use cases can actually execute on them without having to jump through all kinds of hoops, without losing their autonomy, essentially. So that's the key point, I guess. By default, the Google Cloud Platform and any cloud platform is not adapted to your way of working, and at a certain scale, and the scale that we are at Thebol.com, you need tooling that creates this paved road for your engineers that makes them essentially not have to think about all the details, just handles all that stuff for them and lets them concentrate on building their applications. So that's how we use the cloud. We have this paved road, and paved road is like a Netflix concept that developers can land on this paved road. If you obey a bunch of rules, then everything is sort of smooth sailing. But at the same time, there's all these little knobs and levers you can actually tweak if you want to. So then the question that René actually spent a lot of time on, and I will spend a bit less time on, but is interesting. How do we migrate? So so some components had to be moved. So like I said, the BI solution, the vendor was like, yeah, sorry, but we're not going to support it anymore. So we had to move all that stuff to BigQuery because, otherwise we were running on an unsupported platform that was not an option. So that stuff had to be moved. Some things can't be moved because the Oracle database license says you shall not run this in the cloud, so sorry. And by the way, most Oracle product licenses say that, so there's a whole bunch of stuff that we use internally which is either Oracle or got acquired by Oracle after we started using it, that we can't run in the cloud for licensing reasons, unfortunately. So that stuff needs to stay in the data center, and besides that, we also have data centers, small data centers in our fulfillment centers in Waalwijk, which we'll never get rid of because the order pickers need to be able to keep working when the internet connection drops. So we need some local edge computing, to use the fancy buzzword. Sorry? How is it possible that the internet connection drops? So, I mean, because the investment in that is more than just putting some local servers. Yeah. So, but most of the stuff we decided would be moved on a pull basis, which means that we won't be forcing anybody to move to the cloud. We're not going to say, okay, guys, listen, this is all well and good, but you have the next 6 months to move to the cloud, and if you don't, then you have a problem. We want to encourage teams by providing them with information, providing them with tooling. We want to encourage them to make their own decision to move to the cloud. They have to decide for themselves, no overt compulsion. There will be nobody with a sort of whip coming after teams because they're not in the cloud yet. So, and that's one of the benefits is that if teams decide to move for themselves, then they enjoy it more. I mean, I'm a developer, and from my own experience, I can tell you that if you want to create resistance in the mind of a developer, then what you should do is tell him to do that he has to do something, because then the first reaction he will have is, well, probably not. I don't feel like doing it, and it might be a bad idea. So if they decide to do it themselves, then you have more of a sort of psychological buy-in because they themselves have decided to do this. And if they're not moving, then the added advantage that we have then is that there must be something wrong with your tooling, right? If they're not moving, that means that the tooling is not accessible enough, the support is not there, you failed to communicate exactly what the benefits are. We believe in this cloud transition. We think it's a good thing for the company. But if we are unable to impart that feeling upon the developers, then there's something wrong. We have to go back and re-examine why we're doing it. If all the developers say, look, this is all well and good, but we don't think this is a good idea and we're not going to do it, then there is some fundamental problem, and forcing them to move to the cloud will not make things better. So you get the psychological buy-in because they want to do it themselves, and at the same time you're validating the tools and the strategy that you have because they are going along with it. Obviously, some people will still go along with it because they think they have to, but you understand the point I'm trying to make. So the results. That's all right. Improved developer productivity. Cutting these dependencies means that a new service to Pro, we did away with all these forms that you have to fill out beforehand, because really what's the point? You can now launch a service in Pro to Pro in 3 days or even 1 day if you're so inclined, instead of it taking at least 2 weeks. 2 weeks is like the best case scenario in the data center, because you have to wait on provisioning and you have to wait on CI/CD, etc., etc., etc. We self-serviced almost everything, not quite everything, but almost everything. For most of the use cases, developers do not need to talk to anybody except for themselves. We obviously had huge technical improvements in our stack, so we no longer had this sort of do-it-yourself container platform. We're now running on GKE, obviously a huge improvement. We have all kinds of big data stuff that we would never dream of in the DC, or we could never have built ourselves, so there's always benefits there. We have vastly superior cost insights, which I talked about before. Teams can now sort of go to a dashboard and see what does it cost to run the stuff that I run, which was impossible in the data center. We have really big security improvements. So I guess our security department, like most security departments, when we said we want to go to the cloud, they were like, not quite sure if that's a good idea security-wise, because we're running all our stuff with Google, and what's their security like? And build custom servers, custom hardware that has hardware encryption integration to make sure that the OS isn't compromised, etc., etc. All these things that you could never do yourself because you're not Google scale, they do, and they expose to you. So on a lot of fronts, the security gets a lot better than it would be if you were to run your own data center. But on the flip side, if you want to access a database in our data center, then you have a bunch of hoops you have to jump through, like firewalls and all kinds of things all kinds of layers of defense that we've set up. If you want to access a Cloud SQL database and the Google platform, all you need is the correct service account and you have access. So that's like a different kind of challenge that you then need to mitigate, and there's all kinds of ways to do that. So a lot of big improvements, but also a lot of new challenges that we had to solve. And we have around 30 teams of the 70, I guess, that are now running part of their workload in the cloud, and all of the teams are running their big data workloads in the cloud because we had to move that part. So lessons learned. What did we learn from doing all this? Actually, it's interesting because you will see that much of these lessons learned are things that if René had come by 2 years ago and given his talk, then we would have not needed to learn these lessons. But do a lot of training. So we have support from Google. We have one guy, actually it's now more like 3 guys that sit with us twice a week, and they all emphasize like all the successful cloud migration projects that they've been a part of have really emphasized training on the part of the employees of the company that's doing the migration. Like I said, this is lessons learned. So we learned this lesson because we didn't do enough of this at all in the beginning, and arguably still don't do enough of it now. But don't do your migration on the side. It needs to be a program, as René said. It can't be like a hobby project of a bunch of platform engineers when it's a crucial strategic thing for your company. It needs to have focus, and it needs to have the kind of focus that does not get distracted by the fact that something might be on fire in the data center, and those engineers might have to go fix that. Accept the temporary bump in staffing, something that we did not do, but we probably should have done. We iterated on the business case long enough to the point where we convinced ourselves that we could do the cloud migration with the same amount of people that we actually use to run our data center. That's not the case, or that turned out not to be the case. You need more people to do the cloud migration in the beginning. Have strong management buy-in and sense of responsibility, also something that René emphasized. So if you don't have this, then people, first of all, not everybody might not be that convinced that we're going to the cloud because management's not really talking about it all that much. But also, if you have strong management buy-in and a sense of responsibility, if management really clearly sort of lays down the vision about, we're going to the cloud, or we're going to do this, that, and the other, then there's much less confusion in the teams about what choices they need to make in the migration, at least in our experience. The platform should take care of the mundane stuff. So this is, again, with the whole paved road thing. So everything that developers need to do in terms of like boilerplate and setting up a project, copy-pasting thousands of lines of YAML just to get it to work, just make all that stuff disappear into the platform. We are looking at Istio at the moment, running that on GKE for exactly this reason, because it takes a whole bunch of stuff that is actually in the application now, like load balancing, fault tolerance, resilience, that sort of thing, moves it out of the application, moves it into the platform, which means that developers need to worry less about that stuff and can concentrate on writing their business logic. Strike a good balance between team freedom and platform uniformity. So this is, I guess, one of the hardest things to do. You want to give your developers total autonomy, and then at the same time you want to kind of make sure that everything more or less looks the same from a management standpoint, and also that they don't get hacked and you're running a bunch of Bitcoin miners by mistake. This is really hard. I mean, we have this tool that is a kind of framework over the Google Cloud Platform as a whole, and that's great for a whole bunch of reasons, but it's also not that great because it means that whenever there's a new feature in the Google Cloud Platform, we need to make sure that our internal platform supports that feature before the feature teams can use it. So I feel as though we have yet kind of to find the right balance between freedom and the framework in that sense. People need to be able to experiment with these cloud goodies, because the problem is that as long as you're in the DC and the platform team is responsible for what people can use, then people don't dream about this cool new feature that they might be able to use because it simply does not exist. If you're in the cloud, people can look at the YouTube videos from Google Next once every 6 months and say like, hey, they just announced all this cool stuff. We're running in the Google Cloud. Why can't I use this? And then you have a difficult conversation about security and manageability, et cetera, et cetera. So there needs to be a way for people to actually experiment with that stuff in a safe manner. Because if you do that, then you can leverage the innovative skills of your teams. So if you make the platform teams responsible for the cloud only, that means that all the innovation comes from this small group of people that run the platform who are up to here in work, and they're the ones responsible for sort of exploring new things. But it's actually much better and much more scalable if you have all those development teams who can also experiment with cloud stuff and then say, well, I've looked at this and this feature, this would be really helpful. Platform team, please could you build this for me? Obviously, it's better to have 60 teams doing that and filtering that stuff than to have just 4 teams trying to think of what the organization needs as a whole. Listen to the engineers. So this is the part about going to the Google Cloud, et cetera, et cetera. yeah, we did that pretty well, I guess. Sorry, I thought I had one more point, but I guess I don't. And I also don't have this "we're hiring" banner that René had, but we are hiring, so jobs.bol.com. Yeah, so in conclusion, we have been migrating to the cloud for probably longer than we should be at this point in time, but because of all these lessons learned, it's taken a bit longer. We totally believe that cloud is the future of bol.com as a company, but yeah, it's been an interesting ride there. If you have any more questions, please ask them now. Yeah. Yeah.
You talked about the framework and the platform, but bol.com built specifically to support the team. So what does that look like? Is it like a master YAML file, or do you have like a provisioning website you have to log in and then request some?
No, we have a service internally that is basically a thin layer across Terraform, and the service has the necessary rights to actually provision all the infrastructure that is needed, you talk to the necessary Google APIs. The teams define what they need in a YAML file, which is a specification that is particular to that service, and then yeah, they submit that to the service, and the service actually goes and runs Terraform and makes sure that everything is provisioned accordingly. And not just Terraform, but also for some things it runs kubectl commands or gcloud commands, or there's even some Puppet in there, I think. But yeah, so basically it's a thin layer, across a whole bunch of different provisioning tooling that is driven by a YAML specification.
But it's your own or just a dialect? Or
No, it's our own. Yeah.
it's our own.
Yeah. It looks very similar to Kubernetes YAML files because, well, yeah.
So while I heard a lot of parallels between your story and René's, one thing really struck me as being different, and that was your, I think, very much buy into Google's platform and Google's utilities and wanting to use them all.
Yeah.
Whether René was a bit more reluctant to get locked in. Aren't you afraid to get locked in?
No, I am absolutely fearless about getting locked in. So we had this discussion a lot with management who had some unfortunate experiences with vendor lock-in with a company that I shall not name, but is called Oracle. And because of these experiences and because of sort of multiple traumatic contract negotiations, they said, well, if we're going to put all our eggs in the Google basket, that kind of makes me nervous. Should we not hedge our bets somewhat and make sure that we can run in multiple clouds? And to a certain extent, we do that just by using Kubernetes, right? Because Kubernetes runs in AWS and Azure as well. But at the same time, it makes very little sense to me and to the use case we have as bol.com as a company to say, well, we're going to move to this cloud provider, but everything that makes this cloud provider unique and all the sort of competitive edge that this cloud provider has with its own tooling that other cloud providers don't have, we're not going to use that. And it's kind of like shooting yourself in the foot, right? It's like going to Google and saying, well, BigQuery is really awesome, but because we're afraid of vendor lock-in, we're not going to use BigQuery. We're going to invent some sort of other data, some sort of abstraction on top of that allows us to move really easily to whatever AWS has. You're then putting a lot of resources up front into something which you are not sure that you would ever need first, but which you're also denying yourself the actual gains that the platform has to offer you, as opposed to the other cloud vendors. So we discussed this with Google, and Google said, well, you need to have an exit strategy, but to invest upfront into all sorts of tooling that would make it really easy to shift to AWS tomorrow, that's in large part a waste of time and money, especially in the startup phase, where you really want to leverage the advantages of the cloud quickly, and you don't want to worry about, am I going to be locked in? And also, the parallel with Oracle doesn't really hold in the sense that if you look at, for example, AWS has this chart of the S3 storage costs over the past like 15 years, and it only goes down. Why? Because the more people come into this platform, the more economy of scale it has, and the cheaper it becomes. And because Google is also running, Google is running Google on the Google Cloud Platform to a large degree, not entirely, but to a large degree. It is also in their interest to not like jack the prices and scare everybody off, but to get more people in. So the incentives are a bit different than in sort of traditional contract negotiations.
One more difference between your story and the story of René. This pull method, which you mentioned, and René, they just decided we are moving, we are migrating.
Yeah.
Aren't you afraid that it will be never-ending story with pull?
Yes, we are afraid. So the way we often talk about it is that so at first you want this pull method for exactly the reasons I outlined, because it validates your strategy and it validates the tooling you've created. But then, and then a lot of people will move, but then also a bunch of teams won't move. And at a certain point, you have to kind of pick off the stragglers. You have to set a deadline for, okay, we've now been
So you have some deadline in your
yeah, we haven't set the deadline yet because we've just started migrating services. But there will be a point at which we say, look, guys, we don't want to keep these two things around. We have the cloud and we have our own data center. We've proven that we can run. We've proven that we can run everything in the cloud, there's no reason to stay in the data center other than you just don't want to. And it is now in the company's interest for you to move, so please move. But as of now, it's in the company's interest to do this pool thing and to validate our strategy.
So in the end, there will be a lovely Oracle server database living in the data center.
Yes.
It goes around it because all the racks are empty.
Yes. 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 That may well be the case. Yeah.
So you got a lot of service to sell.
Well, that's the other point, and that's you say you have a lot of service to sell. But let's say we could sort of snap our fingers and move everything to the cloud at once. Then we have all this hardware lying around, which is not end of life yet. It would be like throwing a whole lot of money away, essentially. So there's a balance to be struck between getting the benefits of the cloud by moving there, but also not throwing away all the investment you did in the hardware and doing that more gradually. So yeah.
So did you already move like
Are you in the market for spare servers? Or
I thought small ones? No, I hear that they are better in cloud. So.
yeah.
Okay, I'm Sudhir, and first of all, thank you very much for organizing this.
You're welcome.
One striking thing from your presentation was engineers prevailed. So that was really nice to hear that, yes, engineers of your team decided that, no, we have to go to the Google way, and they did. I'm not saying it's not possible, it's rare though. So it says a lot about your probably company culture, I'm not sure.
Did I mention we're hiring? No.
Sorry. My question was more on, since you have started engaging with Google Cloud, how has been, or did you get a need to interact with them for some sort of service support, technical support, and how did that go?
With Google itself, you mean?
Yeah.
Yeah, so we have a support contract with Google, and we actually, so what René said was quite relatable in the sense that we also had all these experiences where we said, wait, this works like this, wait, but that's stupid. How can anybody like actually use this when it works like this? And then we went back to Google. So we have a whole bunch of people inside we have a whole bunch of engineers inside the company that know a lot, but really a lot about running PostgreSQL databases. And they looked at Cloud SQL and they said, well, it's hamstrung in this, and this way. So actually, why would we ever use this? And then we went back to Google and said, well, look at our roadmap, things are coming up, et cetera, et cetera. But we had a lot of, we have more or less daily contact, or at least weekly contact with Google about all sorts of things, because for a lot of things we ran into limitations that products have because we want something just a bit different than what the product offers. And so we get accepted into alpha programs to do new features and that sort of thing. But yeah, there's a lot of contact there, and if you don't have that, so if you're just sort of, especially if you're a big company, if you just rely on the sort of public documentation, then I think it will be a lot more difficult than if you have this sort of intensive contact. And Google wants this as well, right? They want to improve their platform and hear what they're doing wrong. So yeah.
Thank you.
You're welcome. Yeah.
The question is about the security of the data. So do you feel, or maybe do you know that data is as secure as in your local premises versus cloud? I mean, I'm talking about, can the sensitive data, can it be on Amazon or Google? Or
The sensitive data?
Yeah.
So yes, it can. We know this by virtue of the fact that a lot of companies run in the cloud with sensitive data. So 2 weeks ago, I was at a Google event which was meant to get feedback from some of their bigger customers. And I was there along with a guy from HSBC, which is a giant international bank, which runs a lot of very sensitive workloads on the Google cloud. The question is, though, how do you do this? Google has a bunch of ways to manage encryption and that sort of thing, but for us, we haven't yet. So we are not running anything on the cloud with, for example, PI data. So customer data like names, addresses, that sort of thing. We haven't quite found a solution yet whereby we can say, well, we feel comfortable putting that data in the cloud in this manner. There are a bunch of different options you can look at and a bunch of different ways you can solve this problem, but we haven't quite found the one yet that works for us. And there's not really a cut and right solution that Google offers you either, because obviously the first thing we said to Google was, how would you solve this? And they said, well, you have options, this, and this, and this, and the other. And there's not one that really fits our use case perfectly, we feel. So that is a really good question, and that's also one of the biggest challenges we have left, is to how to properly deal with sensitive data in the cloud. Do you encrypt everything, with all the problems that causes? Do you make sure that there are enough sort of high fences around the data that you're sure that the risk of it being exfiltrated is low enough for you to sleep well at night? It's been more difficult than we anticipated, because we kind of assumed, and this was naive I suppose, but we kind of assumed that Google would sort of tell us how to do it and we would just do it that way, but that's not really how it works.
Aren't the European laws much stricter in where you can put your data than the American ones?
I'm not sure about where you can put the data, but yeah, I don't think the US has an equivalent of the GDPR